Hey guys, welcome back to another episode of CleanTechies, the podcast. On today's episode, I had the privilege of speaking with Paul Mertes of CircuitMeter. CircuitMeter has some quite interesting technology that they have developed where they're able to monitor and report data very quickly and accurately within, very minuscule amounts of energy usage within seconds, right? So they're not monitoring 15-minute or hour-long periods. They're able to very, very accurately pinpoint excess energy usage or unknown energy usage, such as when certain equipment might turn on when there's absolutely no reason for it to be turned on in certain areas of the building. So it's very, very cool technology. Has helped save a lot of business owners a lot of money. So very, very cool conversation today with Paul. I hope you enjoyed today's episode. And as always, this podcast is made possible and sponsored by Next Wave Partners.
All right, Paul, welcome to the podcast. Thanks for coming on today. I guess for everybody listening, you want to just introduce yourself. Tell us a little bit about who you are, kind of what your motivation was to get into this clean buildings and smart buildings sector.
Okay. Yeah. Thanks for having me on. My name is Paul Mertes. I'm the President Chief Executive Officer of CircuitMeter Inc. And I've been in the technology and engineering and infrastructure industry my whole career. I graduated as a mechanical engineer, quite a long time ago, and at that time in the early '80s, it was solar energy that was a thing that was rising. More about solving the energy crisis of the '70s than about the things that we're worried about today. We were worried about pollution. We were worried about supply peaks and things like that. And so I majored in thermal fluids in school, and I started a career doing heating, ventilating, and air conditioning design with an engineering consulting company, and got into solar and passive solar designs, in the early '80s when alternative energy was arising for different reasons. But subsequently, actually, energy started to get cheap, and it didn't look like that was going to be a really good way to make ends meet. And I did something I'd been planning to do all along, which was do an MBA. I ended up majoring in finance, and really I went into the business side of engineering, software technology, and infrastructure, and my career followed that path into business management in the companies that I was working in, and I followed a path of international business in Europe, in the Middle East, in Asia, a lot in the States. Turning around businesses that were underperforming, building new businesses and divisions, but if you and ultimately, running a lot of the technology businesses for one of North America's major railways. That all kind of went full circle in 2003, 2004, 2005 when I got really back into the consulting engineering business, and energy was starting to take on a different focus as the challenges of climate change started to become better understood. Alternative energy was really, really rising again because of the clean aspects of it. And after spending some time as a senior executive in a large consulting company, looking at major infrastructure projects in the rail and transit field and in power generation, as well as technology and airports and a lot of large things like that, I had an opportunity to get really entrepreneurial and get into a real clean tech startup, and that was my first opportunity in the entrepreneurial side of things. I'd been always in a sort of a big company environment with a lot of resources and in big projects, and I took on the job of CEO of an emerging geothermal energy company. That was my first experience in raising money and not having the resources to do everything you wanted to do, and talking to investors and all that kind of thing. So I went through that cycle once. I spent some time as a consultant. I spent some time as an advisor to the Mars Institute in Toronto, which is Canada's largest tech incubator. And that ultimately led me to being offered the job of CEO of CircuitMeter, by the fund people that invested in CircuitMeter, one of which Tom Rand had been on a board of the previous company that had been running clean energy. So it kind of went full circle. I've got a real passion for technology, for business, for growth, but also for trying to be part of a solution to one of the greatest challenges I suppose we face, and that's trying to decarbonize the planet in an economic way, not collapse the economy on the way, and create jobs and do it all in time.
Yeah, for sure. I think that's great. I mean, you have obviously a really kind of diverse background, and it's super exciting to see, for people like yourself with the business acumen and the business drive to be able to get into the space. I would consider myself somebody who has that kind of same ambition in my young career. So it's good to hear. I guess I'd be curious to know more about, the technologies that you guys use at CircuitMeter. Kind of what are the problems you're solving? If you were to break it down into each part, like what are the big components of making a building more sustainable?
Sure. I mean, we'll start just with the really big picture. And in Canada and the United States, if you look at all the energy and the money spent on electricity in the industrial sector, in the commercial sector, and in the high density part of residential, apartments and condominiums, 270 billion dollars a year is spent on electricity in those areas. And the U.S. Department of Energy estimates that 30% of that's wasted. So that's a cost of $80 billion a year. So when you're wasting that much money, if you can become more efficient, then it also equals an opportunity. And essentially, it comes down to you can't manage what you can't measure. And in particular with electricity, you can't even, you can't see it. It's not like when you're wasting water somewhere there's a leak. There's evidence, yeah. Right? Energy is wasted by equipment running when it's not supposed to be, when people can't see it, when it's running inefficiently and it's supposed to be running, but it's using more electricity than it should. There's only one way to identify when you're wasting electricity, and that's by measuring it. And having appropriate software to tell you that what those measurements mean, and to do that at the equipment level, which is where energy is wasted, has been a technology that really hasn't evolved in a way that was economic or friendly for the people who need to use it, which are the professional management people in a building or an industrial factory. Sub-metering, which is what we call metering behind the utility meter. It is expensive. It's existed for a long time, but it was really about big machines and big expensive processes like upstream oil and gas, or in an automotive final assembly, where the value of the process was so high that the cost of interruptions or breakdowns was equally high, that you could afford to use very expensive sub-metering technology because it made sense. But none of that technology from the 80s and the 90s was really designed to be affordable and to put software into the cloud, put data to the cloud with software that could make sense of it. That stuff really didn't exist before the founders of CircuitMeter, identified that there was a big gap in the market. And that was the genesis of CircuitMeter. They had the right technical background to put together an architecture of a platform that would solve those problems. And so that was the genesis of CircuitMeter. I'll just take a breath for a second, and then I'll try and go back and see where we are. You wanted me to explain.
Yeah, I'd be curious to hear more, because again, there's obviously many components of a building that make it sustainable. So could you talk a little bit more about how to make it more economical in terms of managing the building? What are the main systems, at least in the core value? I'm assuming there's a lot of really minuscule ones too, but what are the core systems in a building that need to be retrofitted in order to make them more economical?
Well, essentially, every big major building has an HVAC system. That's a heating, ventilating, air conditioning system, which consists of fans and chillers and heat pumps, and and a source of heat that could be steam, it could be electricity, it could be natural gas. So that's generally one of the largest users of electricity. But there's chilled water pumps, and then there's things like lighting. There's electricity. There's system uses. Most buildings have things that are associated with the function of the building. Sometimes there's ballrooms. Quite often there's kitchens. I mean, it just depends on what's going on in the building, whether it's a technology or just a simple office building. But you've got buildings that are as simple as an apartment building that might not even have air conditioning. There's still fans, there's still lights, there's still elevators. To something complex like a multifunction hotel or a commercial office building that has a retail commercial podium at the bottom that goes underground. But essentially, it's those basic things. There's an HVAC system, there's lights, there's fans, there's pumps, there's elevators, and all of those things run on electricity, and the electricity goes through electrical rooms with wires that feed the power to those machines. So with a circuit meter, basically our meter, we can put a series of our meters in those electrical rooms with sensors on the current and the voltage, and those are the two components of power, and we can measure the electricity that's going to all of the major machines. And the thing that's innovative about our design is that it's measuring continuously, and we have all the communications and data processing equipment jammed into this little meter box, so that all you really need to do is put an Ethernet cable into the bottom of it, and it continually sends all the data for all of the equipment in real time continuously to the cloud, where the other component in our platform sits, which is our cloud-based software and energy analytics. And what that does is it takes data from an unlimited number of meters. And one of our meters can take 16 to 48 circuits, which is 16 to 48 machine pieces of equipment worth of data, and an unlimited number, and send it all to the cloud. So you could have 600 or even 1,000 different pieces of equipment all simultaneously arriving in the cloud with big data every 2 seconds. And you can look at what happened in the last minute, or what happened in the last hour, what happened in the last week, 7/24. And with a series of graphical tools and everything else, you can identify when equipment's working that it shouldn't be, et cetera. And you can also compare buildings or factories, et cetera, in a portfolio, and put all those together in the software as well, and then compare building to building, et cetera, system to system, and identify what the good performers are versus the bad performers. And essentially measure everything, compare against what should be happening, and that's when you identify the waste. Now, basically, I can give you some examples.
Okay. Yeah. Go ahead.
Yeah. I mean, we're operating in a large hotel, and the modern building has a building automation system. That's what more sophisticated or even medium tier buildings have, and that's all about controls. And the controls will tell the fans when to turn on and off, and how much air to blow, and whether they needs to be hotter or colder. It's all about thermal energy, and those systems have come a long way in terms of becoming more and more efficient. There's things like variable speed drives to decrease the amount of energy that goes into it. But it's all driven by these control systems. However, control systems can be misprogrammed. Machines can still work inefficiently, and none of this is really ever measuring how much energy is actually being used, or whether they're being operated properly. So with our equipment, we can audit it. It's another tool where you can basically go in and determine, is everything working the way it should. And so, for instance, in this hotel, it was determined that while there is a capability, and everyone thought that that the fans were being turned off according to something that changed every week, and a programmer changed it according to the needs of the hotel, it just wasn't happening, or it wasn't happening properly. And basically all the fans were on all 7/24, and great discovery, easy to fix, didn't cost anything to fix, but the assumption is that this system is working properly. And that's the nature of basically everything that we find. If they knew there was a problem, they'd fix it in the first place. It wouldn't exist. It's all the things that you don't know are happening. And by having a circuit meter system in your building or in your factory, you can firstly go through a process called the virtual energy audit, where you go through and you compare with what's supposed to be happening with what's actually happening. You identify the sources of the anomalies, you fix it, but then within the system, within the software, you can define that condition. For instance, we had a case where base part heaters were coming on in the stairwells of emergency fire exits. No one ever went in there, so they didn't know it's hot outside, and yet the heaters are on. But you're doing this virtual energy audit, you catch it, but instead of just fixing it, we also put the sensors, put in the software. If these heaters come on in the months of May through to November, and the outside temperature is above X, then send an email to the building, maintenance and operations manager telling this happened. And that's a real life case where a message came about a year after the discovery and the fix, because whatever kind of series of events that had occurred that caused the misprogramming to occur, it happened again. And the only thing that was different this time is they found out about it immediately and fixed it the next day, rather than letting $10,000 a month sort of go up in smoke. So the idea is, again, that you can't manage what you can't measure. And if you measure everything, and then you have software to tell you what's going wrong, and then keep it in that condition, keep it in that optimum condition. Once you address all the low-hanging fruit, then you're basically sort of in a new building kind of environment, where it also makes sense to have circuit level or real-time energy management systems, because eventually something is going to break, or someone is going to make a mistake, or something is going to start to wear out, and things will be working inefficiently. And you catch them in real time, instead of eventually catching them when someone notices something, or someone complains, or you have an actual energy audit and you specifically catch it. The idea is to grind this $80 billion a year of waste out of the system, basically improve everyone's bottom line, and to the extent that the electricity isn't generated by green generation, also reduce the carbon footprint. So it's all about energy efficiency.
Yeah, so I guess I'm curious, you mentioned a little bit about creating the solutions rather than just identifying the problems, right? So what are some of the other things you guys will do aside from just simple programming to ensure that, equipment isn't being used when it shouldn't be? Are there other technologies you guys help install into these buildings to, increase energy efficiency among their machinery that they use?
Well, that's coming, but in the end, I think that our technology is pretty much a breakthrough, and almost every building needs to be metered. So we feel that that's a pretty big area all by itself. And there's a lot of controls companies and a lot of equipment companies out there. So we don't really want to get into those areas. But what we do have as part of our software is an API where other software, other hardware, and control systems can basically take the real-time energy data feed and pull it into their own system. So it could be an accounting system, an ERP system, or something like that, but it could be a control system. And we're talking with some companies right now about moving into that area. But what we would do is we would work with the controls contractor, from our end, and basically, interface with them that way. But optimizing, controls from these kind of sensors and this data feed is certainly something that we see coming. And as well as, some of these buildings, they already have third-party energy dashboards. Then what they can do is they can basically pull our data into their systems, because they're integrating usually not real granular data. They're integrating building data, and they can basically get a whole lot more granular. By that I mean, instead of 15 minutes, it's every 2 seconds, and instead of being at the building level, the utility meter data, it's at the machine, at the equipment level. So you can basically add and expand all of those things and turn any building into something that's got state-of-the-art electrical monitoring.
Got it. Yeah. So essentially, by increasing that speed of or the minute how minuscule the data is, you're able to really pinpoint it. So that makes sense.
That's right. The other
I
thing
guess
that's coming, is, or that's here, but it's going to get a lot more important, is both in terms of saving money and in terms of grid stabilization, is demand management. Most states and provinces charge you for your peak demand according to some formula, and it's not insignificant. And if you can reduce your peak, then you can save a lot of money. It's also important, for the grid operators, and it's going to become of increasing importance, because one of the things about getting more green generation onto the grid is that it's more, it's less predictable, it's more unstable. And so the greater the percentage of green generation that you have on the grid, the more smart grid technology is going to be important. The more storage is going to be important, because those are both elements that can help stabilize the grid. And the third thing in that sort of list of weapons to stabilize the grid is demand management, where a building owner can basically reduce their demand in real time if they have on-site storage, or if they have the ability to reduce their demand. And one of the ways for building owners to do that economically is by understanding their existing demand profile. And that's where it comes back to CircuitMeter, because at any given time of the day, we can basically tell them exactly when the peak normally occurs and what the makeup of that is. And are they all like 100% mandatory systems? Are there some systems where they could actually just, with 15 minutes notice, reduce that demand? Or is there an economic case for them to install storage, electric batteries, things like that, and then be able to provide a reduction in demand on the grid and be rewarded by the utility, but have it pay for them, because the use of the battery stored power is cheaper than the incentive that they're paid for by the utility.
Yeah, so essentially not only reducing what they're using, but also being able to use the cheaper energy based off of peak demand. So they can also further reduce their management costs. I'm curious, how tough is it? And I'm not sure, I'm not an expert on the grid by any means, but what is the process to be able to get that interface with the utility to understand, okay, what are the demands coming on this city scale, right? Like knowing, okay, we know that there's standard times, but then there's also some other things that might be less standard, that, okay, let's reduce our energy now so we can get a cheaper price, et cetera. How tough is that to do? Is it something that's already set up with utilities that's relatively straightforward?
It's something that differs from area to area, and for every utility, and those things are evolving. I am not an expert in this field. I know companies that are in that field, and I also know that there's emerging market mechanisms. They've coined the phrase the negawatt, which is how much you'd be paid by basically to reduce your demand. And how you do it is up to you. You may actually, and there are facilities, particularly in the Northeast U.S., where they've installed solar energy, they've installed batteries, everything else to enhance their local ability to generate and store energy, so that they can respond to this negawatt market. But again, I'm really not, totally up to speed on that yet. Although, I'd like to be.
Yeah, for sure. I think everybody would like to be. It's like a big code to understand kind of how it works. But one thing I'm also curious about is what are the upfront costs generally to install CircuitMeter technology? It doesn't seem like it would be too intensive.
Well, that's one of the things about our technology, is that we're dramatically lower in price than the traditional technologies, because we've integrated all the data processing and the communications into basically into our meter, where other meters had to have data loggers and modems and things like that. They had to have third-party data services. They didn't have software, and we've got all of those things integrated. But to give you an example, here in Toronto recently, I mean, we could do, like a whole hotel where it might be up to 30 meters, metering 700 points, and that'd be over $100,000 worth of meters, and by the
Mm-hmm.
time it's installed, the contractor and everything else, it's probably like $140,000 or something like that, and then there's more money to do the systems analysis. But in buildings like that, they're spending almost $3 million a year on electricity.
Yeah, I was going to
and,
say.
and the ROI from finding savings, can be astronomical, can be over 1,000%. But to take up a sort of a standard cookie cutter kind of a building, we recently did one that was 164,000 square feet, and it was for $25,000. We put in sort of 3 meters, permanently installed meters, metering 110 points. Most of basically all the major systems, other than the stuff that's just feeding the individual floors, and that included service money for virtual energy audit, analysis of the systems and everything else, and that worked out to be payback of less than 1 year, taking into account operating costs, and that the building like that you'd use close to $500,000 worth of electricity.
Right. So it's a no-brainer for companies essentially in almost every case.
Yeah. The other two things to think about though are that quite often. So we identified $25,000 a year in operating savings, but also we identified equipment that wasn't running as efficiently as it could because it was getting old. But it's one thing to say that equipment's getting old. It's another to know exactly how much energy that specific piece of equipment is, because the amount of energy it's using is buried in your utility bill, whereas we tell you exactly how much it is, and then you can look at it and say, well, based on what's going on with this specific piece of equipment, if it was replaced or if it had an upgrade on its controls, then the engineers would look at it and get specific. They say, we estimate we could save $50,000 a year if we put in this upgrade. Now it'll cost $180,000, and you do the financial analysis on that. But in this particular case, $40,000 was available from a government subsidy for energy efficiency. So you're looking at $140,000 expenditure with a $50,000 a year benefit. This is less than a 3-year payback, and so it's also available in terms of low cost loans that are available through green finance programs.
Mm-hmm.
Actually was cash flow positive, from the get-go. And then you put these things together, and this matters to commercial landlords and managers, is that if you take $75,000 a year off your operating costs in terms of the value of the building, if it's a cap rate of 5%, that corresponds to an increase in the value of the building of $1.5 million, all because you spent $25,000.
Wow, that's crazy too. I didn't think about that end of it, because that makes a lot of sense. I think it just seems very interesting, the fact that installing these things it really enables them. Obviously, saving their energy is great, but enables them to make informed decisions, like you said, about the equipment. Okay, now we know whether or not this is valuable for us to upgrade, et cetera. So that's interesting to hear. I guess just to wrap it up, are there any other specific things you wanted to mention, or specific things in the future of kind of creating this circular economy and helping just to create a better, more sustainable world that you find very exciting and that you look forward to?
Yeah, I mean, in terms of the future, all this granular data is leading towards machine learning and artificial intelligence, where like we're metering with data samples at anywhere from 12,000 samples a second to, on voltage, 200,000 samples a second. And when you're at that kind of granularity of data, then that leads you to be able to analyze more advanced things, like when machines are starting to break down and problems with the power supply and all sorts of things. And I think the world is going to lead us towards a much more advanced ability to diagnose when things are starting to go wrong, when things are starting to deteriorate, and there'll be a lot of value there. The other thing that's worthwhile, sort of bringing back full circle to what you were saying about New York, is that just at its most basic level, LL88 has specified 2025 as the deadline for buildings to have submeters, and LL97 sort of puts teeth into the overall energy efficiency and energy use, which provides a financial incentive for the landlords. But I think that it's also becoming much more important to people in terms of what building they work in, and that's becoming apparent to building management. They want to provide a green building to attract tenants and maybe command a preferred lease rates, etc. So all of this metering provides more transparency to the end user or to the operator, but it's also something that they can then turn around and use on the marketing side to prove that they're managing their building in the greenest way possible, to actually put a quantitative feel to exactly what's going on in their building. And we even have a thing in our software called the energy window, which can feed like a little flat screen TV that you can put in a lobby and tell people what's going on right now in my building, and allow the landlord to prove to people that they're really walking the talk.
Yeah, I just think this is fascinating. The fact that there's so many of these technologies that are driven by the motivation to create a more sustainable world. They end up doing things like saving the business owners money, but then also, like you mentioned, again, being able to then actually have a higher valuation of their property, and then to also command higher rents. I just think it's just so interesting to see how there's very few negatives, if any, right, in implementing so many of these new clean technologies. So that's very, very cool. Well, I think thanks so much for coming on today, Paul. I really appreciate it. And yeah, definitely appreciate it. And where can people follow you in CircuitMeter? Where can they reach you?
www.circuitmeter.com, and certainly I'm on LinkedIn and make fairly regular posts there, and we're trying to wear the white hat and at the same time basically echo the message you just said, that there are no downsides. This is a smart decision, but it's also the right thing to do too.
Yeah, exactly. Very cool. Well, I look forward to seeing your progress, and we'll have you again on sometime. Thanks so much.
Thanks, Alice.
Thanks so much, guys, for joining in today's episode with Paul. I hope you enjoyed the conversation. I especially hope it brought a lot of value to potentially some commercial business owners or commercial building owners in the audience. Definitely reach out to learn more about their technology. As you heard, it's pretty much a no-brainer, right? If you have these technologies, if you have these big buildings, it's likely this technology is going to pay for itself in a very short period of time. So definitely reach out to them to learn more. Do want to mention, definitely, there's a lot of people who are interested in learning these things. And if you want to get more involved, it's just great to make some connections. Join the Slack channel that we built to help people connect around the world in the clean tech space. Again, whether it's energy or electric vehicles or carbon capture or smart buildings like we've talked about today, definitely reach out, join the Slack channel. The link is in the description. It's a great place to connect and learn. People, everybody's welcome, right? People who don't know much, people who have a lot to share. We want everybody. So please do consider that. Do also want to take a moment to mention our sponsors. As you know, this podcast is made possible by NextWave Partners. NextWave Partners is the leading energy, clean tech, and technology recruitment specialists around the world. So not just serving one specific area, NextWave can serve you in all major areas of the world. And kind of the impetus behind what NextWave does is the consultants aim to be people connectors and to stay ahead of the curve, keeping all of their clients aware of the trends that are coming in the space. So if you are interested, please do learn more about how NextWave can take your career or your company to the next level at www.next-wavepartners.com. That's next-wavepartners.com for those of you listening. And we have a little bit of a big announcement to make this week, actually. Next week on the 27th, so 27th of May, 2021, we will be releasing our first monthly newsletter. CleanTechies, the newsletter. So please do, link, of course, in the description as always. Please do consider signing up for that newsletter, as our goal here is to present kind of a good monthly, one-time, once a month, not too often, overview of what's going on in the industry, maybe some deals that have happened, kind of our thoughts on some of the challenges and trends coming, just a way for people to get more acquainted and kind of learn more about what's going on in the industry. So if you're a beginner or if you're somebody who's been in the industry, I think there's going to be a lot of value here. I'm very excited about this. We've been working on this for a while now to get it all launched with my good friend Randall and Hill, who's also very interested in sustainability and kind of like me, didn't know a lot about how clean tech kind of integrated with sustainability. So I think it's going to be an interesting journey to see. So definitely sign up for that coming again, May 27th. And as always, thank you guys so much for listening to today's episode, and we will see you next week on the podcast.